SolidWorks Simulation, Lecture 3, 2D Simplification. Open the part file. On XY plane, enter sketch mode. Draw a rectangle 300 by 100. Draw a circle at the center with a diameter of 40 millimeters and extrude into 4 millimeter thick. So this is the model that I need. Save on desktop and open a static analysis. I'll first do a 3D CAE analysis. Material, alloy steel. And now for 3D analysis, I will mesh the model and hide the mesh. And I'll apply load on these two areas. With the same magnitude in opposite directions. Now I have completed the 4 steps. This is equal force in opposite direction problem. So theoretically you don't need constraint boundary conditions, but for CAE analysis you still have to apply a soft spring. Right click on the title here and choose properties and check the soft spring option. So this soft spring option is actually a constraint for this kind of problem with equal force on opposite direction. So now the soft spring is the boundary condition or the constraint, and this force is applied. So I'll go ahead and solve the problem. And this is the result. And now I'll open a second study and check 2D simplification and click on the area here. So now it is a 2D problem with stress, a plane stress problem, which is thin plate. And I'll make the thickness 4 millimeters here. Click OK. So now this is the model for 2D simplification. I'll choose material as alloy steel here and mesh. I'll give it a finer mesh for 2D problem and hide the mesh. Now you place the force on these two areas, which is now shown in one line with equal magnitude and opposite direction. And also you need to check the soft spring option. And for this problem, it is a 2D problem, 2D simplification, so I need to check this in-plane effect and choose run. So this is the result that I've got, and I can define the unit. I choose the MPa unit and floating point format with 4 digits under decimal, so I can compare with 3D result here. I can also change the unit into MPa and the format of the result into floating point with 4 digits on the decimal. So I have 0.29 MPa in 3D model, and also a 0.29, 0.89 in 2D model. But now I'll mesh it into a finer mesh. I'll give it a very fine mesh and hide the mesh. I'll calculate the 2D model. For now it is 0.93. So it's very close to 3D result. You can also make the 3D model into a final mesh, right? So you can also run the 3D model again, and again the number is very closer to 2D analysis. So this is a 2D simplification problem for SolidWorks simulation.